In this video, we're going to introduce ourselves to solving systems of linear equations, differential equations, using elimination. We're going to solve two ordinary differential equations simultaneously. That's just the word we use because we're solving them together. Then we're going to have 2 plus dependent variables and exactly one independent variable. Usually we're going to have x of t and y of t. So x and y are both dependent variables, dependent upon the independent variable t. And then, as we've done before in linear algebra, we're going to eliminate one of the variables to obtain one differential equation with one variable. And we can solve that, just like we've done in previous sections. And then we'll do basically some form of a back substitution to solve for the other variable. Okay, just an introduction, a couple of things that we've seen, so it's not a total introduction. Recall that the differential operator is the capital D. We've seen that before. And D applied to y is just the derivative of y with respect to y's independent variable. In this case, it's t. So we can call it dy dt or just y prime. Second derivative, we would say d squared y. And again, it's not d squared, it's not a variable d squared, it's an operator being applied to y. So that would be d squared y over dt squared, which is the second derivative of y with respect to t, and we'll just call that y double prime, or we could. Now, we also looked at L before, capital L, the linear differential operator. We can define that to be some expression involving a capital D, the differential operator. And what would this mean? If this is the case, then if I apply L to x, and I usually like to put a parenthesis around it, it makes it obvious, I think, that it's L of x, L applied to x, we would get d squared plus 4d minus 9 applied to x. Now I'm going to distribute that through. That's d squared applied to x plus 4 times d applied to x minus 9x. And if you remember my saying, when you have a constant here, then it actually becomes negative 9 times x, because there's no differential operator on that term. And so this could be written x double prime plus 4 x prime minus 9x. So that's the linear operator applied to x for this given example.